Welcome to Manufacturing Processes, Machining and Machine Tools lectures by Professor Joyjeet Ghose. This is the 7th lecture of a series of lectures. This lecture will be on Centre Lathe Machine. He will be discussing about types of lathe machines, components of the lathe machine, specification of the lathe machine, operations performed by the lathe machine. So, do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access my videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thank you.
Hello friends, welcome to lecture 7. This lecture will be dedicated to lathe machines and its related aspects. So we'll be discussing about what are the different components of lathe machine, what are the operations that can be performed on lathe machines, what are the accessories that are available for lathe machines. All this aspect will be discussed in this particular lecture. So let's start. Of all the machines, lathe machines or the engine lathe is called the mother of machines because it was one of the earliest machine tools rather, which was invented for metal cutting, and it is quite versatile, but it is not a production machine, and when it is used by a skilled machinist, it becomes a very useful machine tool. So engine lathe, why it is called engine lathe or centre lathe? Engine lathe, it is called engine lathe because earlier days IC engine was used to supply the power for the rotating the workpiece. That's why it was called engine lathe. Nowadays, of course, motor is used, electrical motor is used, and it is called centre lathe because the workpiece is held between two centers, live centers and dead centers. So therefore, it is called a centre lathe. So modern engine lathe comes with wide variety of speed and feed and has large variety of powers depending on the type of lathe you are using. It has different supplied gears along with it for different purposes. A lathe machines can be belt driven or can be all geared. So there are different types of lathe machines. Just quickly go through what are the different types of lathe machines without going into details of each of this type. Let me explain. Okay, this is a lathe machine. Different components we'll be discussing, but here you can see this is a lathe machines and this is the chuck which is fitted to the spindle of the headstock, and this chuck is rotating the workpiece and the tool is removing the machining the workpiece. So these are the various components which we'll be discussing of a lathe machine. This I have downloaded from this particular website. Okay, this is a centre lathe. This is a tool room. The tool room lathes are smaller in size and are very much versatile, has large ranges of feed and speed. These are mainly used for making prototypes or tools. So that's why it is called tool room lathes. Turret lathes, we'll be discussing details in turret lathe. Turret lathes are semi-automatic lathe machines mainly used for production work. Automatic, but it is also an automated machine where number of cutting tools are operated by means of a cam to produce a particular component. It is also a production machine. So this is a particular single spindle automated lathe that we have in our department. You can see these are the cam and several tools are here. Several tools are there fitted here. So this cam operates the different tools. This is a 6 spindle automated lathe. This is a copy lathe. In this there is a template of a workpiece. So a stylus follows the profile of this template, and this movement of the stylus is reproduced on the actual tool by a hydraulic mechanism. So this is called a copy lathe. You can see this is the workpiece and this is the stylus. The stylus moves over the workpiece like this, and this is the hydraulic attachment. Then of course now we have the modern lathe, which is called the CNC lathe or computer numeric control lathe, where different programs can be stored and can be used repeatedly. Same program can be used to produce components repeatedly. same components repeatedly. And retrofitted lathe. So retrofitted lathe was one of the first steps towards use of electronics in machine tools. So retrofitting means basically making some axis automatic. Here, this is particular DRO is used. This is basically a linear movement measuring instrument is used, or sensor is used, which measures the this axis travel and is represented here. X, Y, Z coordinates of that travel is represented in this manner. This is a high speed lathe. It's a quite large lathe. You can see large size workpieces can be held, or long workpieces can be held. This is an HMT NH22, a very popular model of HMT lathe machines. This is a particular engine lathe. This is a bell driven lathe. You can see bell driven lathe here. This is a mini lathe. So with this we come to the components of a standard engine lathe. We will discuss the major components. So this is a block diagram of an engine lathe. So you can see the most basic component is the bed. Now bed and bed ways, and top of it is machined accurately to form ways. Now bed is the structure over which all other component is mounted, and the entire vibration and load of the machine comes on the bed. So bed must have a good damping properties, and for that cast iron is used. Cast iron is considered to be having a very good damping properties, and therefore cast iron is used for making bed. Nowadays we use different materials having different very good damping properties, but initially cast iron was used. Now also many lathe machines uses cast iron bed. Now this cast iron bed has stiffeners, so that to increase the rigidity of the bed. I'll show you the bed images of bed, and the top surface of the bed has equilibrium machine on which the carriage and the tailstock can move. It can be inverted V type bedways, or it can be dovetail type bedways. So most uses in inverted V bedways. On this side is the headstock, on this side is the tailstock. This is the carriage. Carriage consists of the cross slide, the compound rest, the tool holder, the carriage handle, apron. All these 5 components makes the carriage. This is the lead screw, and there is another rod which is called the feed screw. So feed screw and lead screw are sometimes combined to form a single rod. So with this we move on with the headstock. Headstock is on the right hand side, and probably one of the most important part of a lathe machine. So the power from the motor is supplied to the headstock, or to be specific, power from the motor is supplied to the spindle of the headstock, and the spindle is rotated. And from that rotating spindle, if in other component power is required, headstock supplies the power. That means for feeding the carriage, power is supplied from the headstock, but principally from the motor the power is supplied to the headstock. Now the way by which the power is supplied to the headstock, let's say if it's a belt and pulley arrangement as in this one in the figure, there are 3 step pulleys. So the speed can be varied in 3 steps here, and the power drives the spindle here. So this is a belt driven pulley, belt driven lathe machines. Sometimes gear is used between the motor shaft and the spindle shaft, so that is called all geared lathe machine. So this spindle is hollow and has a tapered hole, so that we can feed the live center, and sometimes it has a threaded nose where we can feed the chuck, or screw on the chuck, the faceplate, etc. And it has tapered hole so that collates or live center can be fitted directly into the spindle nose. So this is how it looks inside the headstock. Maybe the power is driving this, and this is the headstock. The motor is driving this gear, and the power is supplied to the headstock by a gear train. So I was talking about beds. So this was the bed, and these are the bed ways, and you can see these stiffeners here to increase the rigidity of the machine. And this is from the other side, from this side, from tailstock side. You can see this is inverted V, inverted V, the tailstock and the carriage moves over these ways. The accuracy of the machine will depend how accurate the bed ways are. So this is the headstock. You can see these are the 4 steps. That means 4 steps are there, so you can vary the speed into 4 steps. And this is a back gear arrangement. This back gear arrangement, when it is attached, so basically it's a back gear which reduces the speed beyond its limit. So this is used when we are cutting thread. We want very slow speed, so then we engage the back gear to reduce this speed. And this is the nose of the spindle. This is the nose of the spindle. So here we will mount the jack or catch plate or face plate. This is the tailstock. The other end, tailstock is on the right hand side. So there is a dead center here. Tailstock is used for holding or supporting the workpiece from other end. Sometimes we fit a tool here and we can carry out operations like drilling operations, reaming operations, etc. And this is also used for holding the workpiece. You can slightly move in this direction or in this direction, and we can eccentrically hold the workpiece for taper turning. So tailstock serves 3 purposes. And the carriage consists of saddle, cross slide, compound rest, tool post and apron. Okay, we'll start with saddle. Saddle is basically an H-shape casting which is mounted on the bed ways over which the cross slide is mounted. So this H-shape casting is the saddle. On top of it, the compound rest, the cross slide is mounted. On top of the cross slide, the compound rest is mounted. So this is the cross slide. The cross slide is used for giving feed in this direction, for giving in this direction. And remember, the carriage can be moved manually or it can automatic feed can be given to the carriage. And this is the compound rest. There is a T-slot here on which the tool post is fitted, and the base is circular, which is graduated and degrees, and this compound rest can be rotated at a particular angle and can be fixed. So this is required during taper turning or various cuts that is taken. Mainly used in taper turning. You can rotate the compound rest. And T-slot on top of it is used for fitting the tool post like this. Tool post is a single tool post. This is a square direct tool post. 4 tool can be fitted and it can be changed quickly. So it's a quick changing square direct tool post. This is a quick change square direct tool post. And the apron. Apron is the front panel along with the components and mechanism which is needed to move the carriage manually as well as using the power. It houses all the controls, levers, etc. And the feed rod. Feed rod is a long shaft way. Feed rod, when engaged with the carriage, then the carriage moves automatically. And lead screw. Lead screw is a threaded screw, which when engaged can be used for thread cutting. Lead screw has a definite pitch. So how do you specify a lathe machines? We have finished with the various components of lathe machines. Now we'll discuss how to specify a lathe machines. So when you go to a market, we want to buy something, we have to specify that particular component. Now how do you specify? If you want to go to market and want to buy lathe machine, how will you specify? The major things that we'll be discussing is the maximum swing diameter without touching the bed. So this is the largest diameter of the workpiece that can be held and can run over this on the spindle without touching the bed. This is the bed. And the maximum swing diameter without touching the cross slide. So this is in this vertical plane and this is in horizontal plane. So this is maximum swing diameter or maximum size of the diameter of the workpiece which can clear the cross slide. That is the maximum swing diameter without touching the cross slide. And of course the distance between the center and the length of the bed, plus the ranges of speed and feed available and the power that is available. So this is how you define a lathe machine. So different types of tools are required for lathe machines or their used in lathe machines for thread cutting. It can be left-handed tool, it can be right-handed tool. Left-handed tool moves from left to right, and right-handed tool from right to left. Mostly we use right-handed tool. So we have cutting of tool, we have radius turning tool, thread cutting tool, chamfering tool, parting tool, turning tool. So different types of tools are used in lathe machines. How do you change the cutting speed? We change the cutting speed by, or RPM rather, by, in this case belt and pulley will shift it to different pulleys of different sizes. In case of all geared lathe, we will be changing the gear ratio and will be changing the RPM of the spindle. So you can see these are the control levers, the charts are there how to select all these things. Okay, the first operations that we'll be discussing is a turning operation. Turning operation is basically a operation that is performed, most frequent operation that is performed on a lathe machine by rotating the workpiece and feeding the tool longitudinally. Now, when you rotate the workpiece and feed the tool longitudinally, the surface that is produced is basically a cylindrical surface parallel to the axis of the rotation. So this is called turning operation. So this is a straight turning operations, and there can be taper turning. Taper turning means uniform increase or decrease in the diameter of the workpiece. Now we can do taper turning by several methods. By form tool, by setting over the tailstock, by swiveling the compound rest, by taper turning attachment, and by compound feeding it. So the geometry of taper. So here, if this is taper turning, this angle is called the taper angle. This is half of taper angle. So this is alpha. So if this length of the taper is BL, if this is capital D and this is small d, so we can find out that a 10 of alpha is equal to capital D minus small d by twice L. If K being D by D by L, D minus D by L, so 10 alpha is equal to K by 2, or K is equal to twice 10 alpha. So with this, this is a full taper angle, this is half taper angle. So for form tool is basically any tool whose shape is reproduced on the workpiece. So if we want to cut a small taper over a very small length, we can use a taper turning method by form tool. So you can use the form tool and press it directly perpendicular to the axis of rotation, and the shape of the tool is reproduced on the workpiece to generate a taper of very small angle over a very small length. Then that is called taper turning by form tool. So this method is limited to turning a limited length of taper and limited angle of taper. Okay, the next method is taper turning by setting over the tailstock. I can set over the tailstock and this method is suitable for cutting small taper over large length. So if taper angle is small and the length is large, then this method can be used. This is the mathematics behind it. So depending on the angle, the set over is decided. The set over is given as capital D minus D by 2. So this can be found out. You can go through it. And taper turning by swiveling the compound rest. The compound rest can be swiveled at any particular angle and fixed, and then if you give a feed, it will cut a taper like this. So this is used for a very steep taper over a very small length. So this method is limited to turn a short but steep taper owing to the limited movement of the cross slide. The cross slide can move only in this direction, so very short length taper can be cut. And lastly, the versatile method, if you are using a taper turning attachment. So this is the taper turning attachment. There is a guide wedge, and these are calibrated at angles. The guide wedge can be fixed at any particular angle depending on the angle of the taper and can be fixed. Now there is a screw which will loosen it from the saddle. Okay, so once it's loosen it from the saddle, so as it moves, the carriage moves, it will follow this thing, this guide wedge. Okay, so it will follow this guide wedge. And you can cut small taper over large length, large taper over small length, all variety of taper can be cut. So here you can see this is the taper turning attachment. So this can be rotated at a particular angle and can be set. So here we loosen it. The cross slide will be loosened from the saddle here by loosening this screw. Once it is loosened, If we give feed here, so it will move according to these ways and not this way. So it will move in a eccentric manner, cutting taper. So there are other methods, other processes also. Facing operations. Facing operations is normally the first operations that is performed on a lathe machine because of a particular reason. Facing operations is basically generating a flat surface at one end of the workpiece. In this case, the workpiece is rotating and we feed the tool in this direction. So as it reaches halfway, the entire surface is flattened. Now, why I have said this is the first step is because the operator uses this as a first step, because this is the reference from which the operator will be measuring the distance. So therefore, facing is normally the first operation that is performed on a lathe machine. Chamfering. Chamfering is basically beveling one end of the workpiece using a chamfer tool. And knurling. Knurling uses this type of tool, which is diamond shaped roller having cutting edges on particular angle. So if this roller is having angle in this direction, the other roller will be hanging in this direction. So each roller will cut a diamond shaped pattern on the workpiece. You have seen in many metal handles this type of patterns. So this is mainly used for decorating purpose and for forming a grip. So this is knurling. Grooving and recessing. Grooving is basically reducing the diameter at a particular length of the workpiece. And we have drilling, rimming. Drilling and rimming, we feed the tool into the tailstock, and tailstock is moved forward as the workpiece is rotating. The tool is stationary. Tool is not rotating, workpiece is rotating, and tool is fed into the workpiece. Boring, the boring tool is held in the tool post, and we carry out boring operations. Parting tool, parting operations, we use parting tool. Parting tool is basically cutting the workpiece. So if you feed it in this manner, so once it reaches the center axis, it will be parted. And thread cutting, it can also be done on lathe machines. Thread cutting is slightly complicated in lathe machines. In normal engine lathe, it is slightly complicated. We have to engage the lead screw for thread cutting, and a particular ratio between the spindle and the lead screw has to be maintained so that the thread of particular pitch can be cut. So there is a complicated conclusions. I am not going into that. So in that manner we can be cutting thread on a lathe machine. The details are given here, you can go through it. In this manner, this is the headstock and this is the lead screw spindle, and from here we have a gear train has to be maintained to cut a particular thread on the workpiece, or thread of particular pitch on a workpiece. So with this we come to the conclusion of lathe machine. I hope you have liked this video. Thank you for watching.